Hello everyone! Welcome to the next section of the course, Proper Data Fetching. The goal of this section is to show the different data fetching patterns that we can put in place in a React application. It is important to know how the parent can communicate with its children and the other way round. We will see some real-world examples of data fetching, transforming a base component into a well-structured one using HOCs. Finally, we will see how existing libraries such as React Refetch can save us a lot of time by providing the core data fetching functionalities we need. Now we move on to the first video of this section that deals with data flow. In this video, we are going to learn to build a proper data flow for sharing data across multiple components in our application. React enforces a very interesting pattern to make data go from the root to the leaves. This pattern is usually called Unidirectional Data Flow. As the name suggests, in React, data flows in a single direction from the top to the bottom of the tree. This approach has many benefits because it simplifies the component's behavior and the relationship between components, making the code more predictable and maintainable. Every component receives data from its parent in the form of props, and props cannot be modified. When the data is received, it can be transformed into new information and passed to the other children down the tree. Each of the children can hold a local state and use it as a prop for its nested components. Let's delve into the code creating a counter component which starts from 0 and has two buttons, one for incrementing the value and one for decrementing it. So we start by creating a class that extends the component function from React. The class has a constructor where the counter is initialized to 0 and the event handlers are bound to the component itself. The event handlers are simple and they just change the state, add or remove a unit from the current counter. Finally, inside the render method, you can see that the current value is displayed and the buttons with their onClick handlers are defined. Moving on to child-parent communication and Callbacks Function. There are no major issues with this component apart from the fact that it does multiple things. It holds the counter value into the state. It is responsible for showing the data. It contains the logic for incrementing and decrementing the counter. It is always a good practice to split components into smaller ones, each with a very specific behavior, to improve the maintainability of the app and make it flexible when requirements change. Consider that we need the same plus and minus buttons in another part of the application. It would be great to reuse the buttons we defined inside the counter, but the question is, if we move the buttons away from the component, how do we know when they get clicked on so that the counter can be updated? In React, when we need to push information or simply trigger an event from children to the parent, we use callbacks. We create a buttons component to display the increment and decrement buttons, which, instead of firing internal functions when they are clicked on, use the functions received from the props. It is a simple, stateless functional component where the onClick event handlers fire the functions received from the props. Now it is time to see how to integrate this new component into the counter. Let's switch back to counter.js file. We just replace the original markup with the component, passing the internal functions to the new child. So, as you can see here, we replace these lines of code with button and onDecrement attribute. Everything else remains the same, and the logic is still in the parent component. The buttons are now dumb, and they are only able to notify their owner when they are clicked on. So, every time we need the children to push data into the parent, or simply inform the parent that something happened, we can pass callbacks and implement the rest of the logic inside the parent. Further, we will learn about the common parent. The last thing to be done to clean it up completely is to remove the display logic from it. To do that, we can create a display component that receives the value to display and just shows it on the screen. In general, our goal is to make components unaware of the data source so that we can reuse them with different sources in various parts of the application. Using the new component in the counter is easy, we just have to replace the old markup with the display component. As you can see here, two sibling components are communicating through their common parent. When the buttons get clicked on, they notify the parent, which sends the updated value to the display component. This is a very common pattern in React, and it is an effective solution to share data across components that do not have a direct relation. The data always flows from parents to children, but children can notify the parent and make the tree re-render with the new information. Every time we need to make two unrelated components communicate, we have to find the common parent between them and keep the state at that level so that, when the state is updated, both components receive fresh data from the props. In this video, we have successfully learned about different types of data flow.